In this video tutorial, we're going to look at using the Kongsberg EM raster factory. The Kongsberg EM raster factory is designed for processing Kongsberg EM datagram files. These are files that contain all sorts of information during the acquisition of multibeam echosounder data collected by Kongsberg's EM Series multibeam echosounders. The factory is specifically designed to look at processing of sounding data. So rasterization of what Kongsberg called the XYZ datagrams, or the soundings, and their associated positional and tide information only. So let's go ahead and look at a Kongsberg datagram file. So I'm going to launch the raster factory, and you'll notice that there are 4 different methods within the Kongsberg EM raster factory processor. The first one at the top is read content report. So this is going to read and summarize the information about all the different types of datagrams that are in this Kongsberg file. I should point out that the Kongsberg EM datagram files are generally referred to as .all files because they contain all of the datagrams for the acquisition from that system. So let's go and choose an all file. I've got one here, and I'm not going to choose an output file because by default the content report will be written to the process info window if I don't supply one. But if I wanted to write out the content report to a specific text file, I could specify it here. Okay, let's open the process info and see what's in the file. So it's telling me I have 188,000 or so datagrams in the file. It's got the acquisition times in that file and the spatial extents of that file. It tells me what model instrument. This was a EM302 echo sounder, and it tells me what types of datagrams are in the .all file. The ones I'm interested in are the XYZ datagrams. They're the ones that contain the actual soundings. And I'm also interested to see whether there's positional information, attitude information, and if possible, if there's any tidal information in here. Now you'll note that there's no tide information in here, but I know for a fact that this all file has been tide corrected in real time during acquisition, so it's not such a big deal. Okay, let's now go and actually try to import one of these. So I'll go back to the processor, and I'm going to choose the process XYZ datagrams method. Again, I'm going to choose the same all file, and it's asking me if I have a tide file. So if, for example, this datagram file was not tide corrected, then I could choose an ASCII CSV file that provides the tidal information and use that as the basis for correcting the tide correcting the soundings in there. Details about how that tide file should be formatted are included in the help file. We might have a look at that a little bit later. So I'm not going to specify one, and I'm not going to choose to write output files. If I wanted to output the converted all file to a raster, then I could specify an output folder, the format that I wish to write the output rasters to, and the file extension name for those rasters. But I'm not going to do that. I'm going to have my imported raster return straight into memory in the ramp graphical user interface. Most all files are written in have geographical coordinates in there, so I need to pick an ellipsoid. In this case, I'm choosing GRS 80. I'm going to use a cell size of 0.00005. This is in decimal degrees because the data is natively geographical. And then I can choose the output types that I want to output. So I have a series of different options. I can output the positional data. This will apply if I have chosen to write output files. It will write the positional data to a ASCII file. The same with the tide datagrams. If there were tides in my all file, I could export the tides. But I'm going to choose to import the depth datagrams and create a raster from those. But I could also use seabed reflectivity, the incident beam angles, the corrected incident beam angles, the insonification azimuth, or purely the number of soundings that are within within my raster cells. So the I guess the density of soundings. I'm just going to choose depth. This asks me if I want to reverse the depths from negative to positive or positive to negative. I'm just going to leave it as true. And my binning method is going to be a moving mean. We've discussed moving means before in the ASCII XYZ binning factory, so I won't go into it again. The output time format is important if I'm exporting, say, tides and positional information into a text file. I can choose what time format they're written to. So I'm just going to click OK, and this should now process the XYZ datagram's depths. Okay, and it's come in here, and I'm going to render it. Okay, you can see that when this data was acquired, the vessel was yawing, or the sensor was yawing quite a bit. I'm just going to go and zoom in here and inspect these datagrams a bit more and render that one. Right, you can see that we probably didn't specify a large enough binning size, but what we might do is we might put a kernel on this to fill in some of these gaps. Let's do that now. So I'm going to choose my local statistics. I'm going to use a mean kernel. I'm going to choose that clip that I made. I'm going to give it a kernel size of 9. Let's see what that does. Okay, so let's render that. Yeah, and that's a lot better. I've now managed to fill in some of those gaps. So that was a very quick tutorial on how to import XYZ datagrams from Kongsberg EM files. There's a series of other things that you can do in this tool as well. You can batch process a whole folder of .all files and output those, choose which datagrams you want to import, and then output them to a series of files in a particular folder. And I can also extract the sail lines or run lines from these files as well. So again, I create an input of, I select an input folder and a series of .all files and an output folder and the name of an Esri shapefile, and all the run line information from those all files will be written to that shapefile. So it's a really good way of indexing what survey lines you've run, and it's attributed with the name of the file, so you can easily find back which all file applies to which line number. I hope this tutorial has been of use to you.